Okay, one more video on metals. This will hopefully be a short one. This is a video about metallic bonding, but more specifically focusing in on alloys. So again, metallic bonding is the electrostatic attraction between positive metal ions and the delocalized valence electrons between them. So that's the model we think of when we zoom in on a metal. It has this ordered but yet sort of loose arrangement where you've got a geometric arrangement of positive metal ions with valence electrons that are allowed to move delocalized between all of the ions. And so we describe that bond as very non-directional because the positive ions are attracting different electrons at all times as they move past them. Okay, now to skip ahead, an alloy is actually probably what you're really familiar with if you think of metals that you use in your daily life. Alloys are mixtures of different metals and sometimes nonmetals, but we think of an alloy technically as a solution or a homogeneous mixture, a uniform mixture at the atomic level of two or more metals. And the inclusion of different metals or other metal atoms and sometimes nonmetal atoms into a metal's structure can give metals what we would call enhanced properties. Okay, so what are some of those enhanced properties? Well, alloys compared to pure metals tend to be harder, they tend to be tougher, they tend to have more tensile strength, which is very important in engineering. It means that they can sort of be pulled and bent on with much more force without breaking. They often have greater resistance to corrosion, and they often have higher melting points. So alloys are extremely, extremely important. Some examples to skip down here. Steel. Steel is an alloy of iron that has some carbon infused into it. And steel is, what's essentially propping up the majority of the framework of buildings and bridges all around you. It's incredibly useful, but having just pure iron is far less effective as a material. Stainless steel, what your cutlery is probably made out of, has additional elements mixed in like chromium and nickel, which prevent the steel from corroding. And so it maintains that really shiny outside exterior, despite being used in all sorts of different solutions and being subjected to heat and all these other things. The chromium actually creates a layer of chromium oxide on the outside of the metal. And so even if that gets destroyed or wiped away, the chromium beneath it will reoxidize and create that stainless, shiny outside again. So it's pretty amazing stuff. Brass is an alloy of copper and zinc, and it has that nice gold color. That's what we made in class during our demonstration. Bronze is a mixture of copper and tin, not copper and bronze. But bronze, the Bronze Age was one of the first alloys that was made was bronze because there were a lot of minerals that naturally had a lot of copper, and both copper and tin in them, and they could be fused together to make bronze metal. And then gold, the gold that's in jewelry is actually an alloy. It's largely gold, but actually it's only about 75% gold usually, and it has silver and copper mixed in with it. And so while that you might think that you've been ripped off for not having pure gold, it's actually better for the purposes of lasting as jewelry because pure gold is very soft and would not be very effective in holding its shape as a piece of jewelry. So why does this work? Well, when you have an alloy, so you're mixing in these different atoms, these different ions into the metallic lattice structure, right? And so it can be more of a mixture or just a slight mixture. And predominantly it could have one metal with just a little bit of another metal. By mixing in different ions and atoms, they can fill in the spaces in the metallic lattice more completely, right? So the idea is like if you packed a bunch of golf balls together, there'd be a fair amount of space between all the golf balls. But if you packed a bunch of golf balls and marbles together, the marbles could better fill the spaces in between the golf balls, and that would therefore make it like a more packed together, more difficult for both kinds of balls to actually slide past each other now. And so having different atoms or ions within the structure creates more directional bonding. It's a little bit more, it has to keep a little bit more of a regular arrangement of how many of this metal versus how many of the other metal within the structure. And so that ends up making it that there's like a more rigidity to the structure. And so the metals tend to be harder and tougher. And if you try to pull them apart, they tend to resist that more. So that gives them the greater tensile strength. The greater resistance to corrosion is more about unique properties of the metals that you're using, like using chromium is a good way to add that greater resistance to corrosion. Higher melting points is also because the attraction may now be stronger between the two different kinds of metals because they are able to pack closer together. The closer they get, the more they can attract. So by being closer together, we end up often getting higher melting points out of alloys than out of the pure metals. So you don't have to explain too much of this in the IB. They mainly want you to know that an alloy is a mixture or a solution of two or more metals, and that alloys tend to have enhanced properties, and you should probably be aware of what some of the properties are that alloys may have as opposed to their pure metals. And most of it comes down to the idea that the different metals can pack more compactly, more efficiently together, and therefore attract more together than the pure metals. But I doubt you would even be asked to explain that much. Just some follow-up, just to recognize that we do use a ton of metals and alloys in our everyday lives. Aluminum is used for things that need to be lightweight, has a very low density. It has its own layer of aluminum oxide on the outside, which makes it resistant to corrosion. So it's very useful. Zinc gets used as a coating on iron, and it helps protect iron or steel from corroding. So that's what's called galvanized steel. If you've ever had a nail that is called galvanized steel, it has zinc on the outside, and that helps protect it from rusting. Copper's used all the time because it's such low reactivity metal and very high conductivity. We use it in our electrical wires. And mercury is the only metal that's liquid at room temperature, and its volume changes significantly with temperature, and therefore it's useful in highly accurate thermometers. Alloys that you use all the time: steel, stainless steel, brass, bronze, and gold jewelry, like we already talked about. So anyways, that's a brief overview of what alloys are and a little bit about why they have those enhanced properties.